Hello my scholars, this is my school channel and my name is Abiola. For this video lesson we are going to be tackling the JAMB CBT past question for the subject physics the year 2009. Do not go anywhere, stay with us because we'll be right back. Welcome back to my school YouTube channel, and in this video lesson we are going to solve questions 1 to 17. So let's start with question 1. Diameter of a small ball bearing, thickness of a piece of paper, diameter of a measuring cylinder, and length of a piece of wire. Which of the above can be measured by using a micrometer screw gauge? Okay, so depending on how small, what diameter of small ball bearing we're talking about, all right, maybe for greater precision, I can go for micrometer screw gauge. Although some presentation will tell you that vernier calipers are more applicable. All right, so, okay, based on the statement supplied, all right, so what I'm going to go for is we can use the micrometer screw gauge, all right, to measure the diameter of a small ball bearing. Bear in mind that this is used to actually reduce friction. All right, we have different types of bearings. We have ball bearings, we have the fluid, we have the roller, we have the linear, and the likes. Okay, so I'm going to select diameter of a small ball bearing because of this presentation, and we're talking about the thickness of a piece of paper. So those are the things that we can use to you can use the micrometer screw gauge to measure rather. Okay, so when you come to diameter of a measuring cylinder, preferably I will go for vernier calipers. So the correct option here for this presentation is option B, 1 and 2. Question 2. What is the acceleration between 2 points on a velocity time graph which has coordinates? We have for the time, okay, that is on the horizontal axis, we have 10 seconds, all right, then against 20 seconds. Then we have 15 meters per second, that is for velocity. So remember the graph is velocity time graph, that is acceleration. So basically, acceleration equals change in velocity over the time required or the time taken. So change in velocity right here is 35 minus 15, that is 20, over the time taken or the change in time, which is 20 minus 10, that is 10. So I have 20 over 10. Okay, that gives me 2 meters per second square. Square, that is the unit. Meter per second square is the unit for acceleration. So what I just did is just from the formula A equals V minus U over T. All right, so you can see the difference in the time required, 20 minus 10. So the correct option is option D. 3. A bullet fired vertically upward from a gun at 2.0 meters above the ground reaches its maximum height in 4.0 seconds. All right, so calculate its initial velocity. Okay, so this question is very easy, but as well we need to pay attention to details. All right, so we can see that we are told to calculate its initial velocity. So it's not clearly specified that we should look for the maximum height, okay, after getting our initial velocity. So just to get the initial velocity, we can use this formula, V equals to U plus AT. All right, but right now we're not talking about this kind of acceleration. We're talking about acceleration due to gravity, isn't it? Okay, so vertically upward, that means it's not in favor of gravity. So this sign will become minus. So I should have V equals U plus minus GT this time around. Okay, minus GT against gravity, isn't it? So from the question we are given G as 10, all right, and at maximum height this equals 0. So that is 0 equals U minus 10, right? What's our T? The time given there is 4 seconds, that's times 4. So I have, so if this U comes here or this comes outside, so let's say this comes outside, this is 10 times 4, that is minus 40. Minus 10 times 4, that is minus 40. So if minus 40 comes outside, it becomes plus 40. So I have 40 plus 0 equals U, and that is U equals 40 meters per second. All right, so if I were to look for, if I was asked to look for the maximum height, then I would have proceeded with other equations or another formula. So 40 meters per second. Let's secure that from the options supplied. We can find that in option C. So option C is the right option. Question 4. The motion of the tires of a moving car, the motion of a loaded test tube oscillated vertically, the beating of the heart, the stone tied to a string and wheeled around, then the motion of the pistons in a gasoline engine. All right, so which of the motions above is simple harmonic motion? Okay, simple harmonic because of the motions earlier mentioned. So if I'm going to select the simple harmonic motions here, I'm going to pick this, the motion of a loaded test tube. I'm going to pick 2, I'm going to pick 3, and I'm going to pick 5. Those are the correct examples for simple harmonic motion. I, which is 1, the motion of the tires of a moving car, that can be well presented for rotational motion, okay? Then high V, a stone tied to a string and wheeled around, that is for circular motion. So the correct option should contain I, high, then V. All right, so that is 2, 3, 5. Option B carries this statement. So option B is the right option. 5. If a cage containing a truck of coal weighing 750 kg is raised to a height of 90 meters in a minute. Okay, so what is the total power expended? All right, so we're just going to use the formula P, that is P for power, right? Mass times gravity times height over time taken. So I'm just going to use this, right? The mass given is 750. Acceleration due to gravity, that is 10. Then the height is 90, right? The time taken, that is actually in a minute, and that is 1 minute. 1 minute equals 60 seconds. Right, so I can have 6 here, 1, 6 here, that should be 15. So 15 times 1, that is 15 times this. I should have 11,000 to 50. All right, so if I'm going to bring that to probably to kilowatts, right? That should be 11.25 kilowatts, or you can have 11.3 kilowatts. So let's see what the options present. Okay, so let's go back to the screen. So 11.25 kilowatts or 11.3 kilowatts. Yeah, we have 11.25 kilowatts, option C. So option C is the correct option. 6. An object of mass 80 kg is pulled on a horizontal rough ground by a force of 500 Newton. What is find the coefficient of static friction? So either you are asked what is the coefficient of static friction, or find the coefficient of static friction. Just use this formula. Okay, so we can represent this by something that looks like a U. Okay, because frictional force over the normal, and this is given as 500, right? This is given as 80, but we can't use 80 because we have to convert from kg to Newton. So that is 80 times 10. All right, so 80 times 10, 0, 0. Then we have 5 over 8. 5 over 8, when you divide them, that should be 0.625. I can recollect that the question actually reduced it to just 1 decimal place. All right, so that should be 0.6. Because this becomes 3, and 3 becomes 0, so there's nothing to give to 6. So we should have 0.6. Remember, Newton has striked out Newton. Newton has cancelled Newton. Okay, if you want to put it that way. So no units available. So we have that in option D. So option D is the correct option. Yes, we strongly recommend that you have a JAMB CBT experience. All you just need to do is to click on the link in the description below. It's going to get you to the Myschool website. All right, so right there you get to download the Myschool mobile app for your Android devices, or you can get the Myschool software for your laptops and computers. So why not try downloading it right now? So join me as I solve question 7. If a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, okay, so its velocity ratio will be what? All right, so remember that VR, or velocity ratio, when it comes to inclined plane, has the simple formula. All right, VR equals 1 over sine theta, right? And right here I have 1, my theta is 30, 1 over sine 30. So I know that sine 30 is actually 0.5 or 1 over 2, right? So that should be 1 divided by 0.5, or I can say 1 divided by 1 over 2, isn't it? So this is 1 over 1 times 2 over 1. So I should have 1 times 1, 2, 1 times 1, that is 1, so 2 over 1 is actually 2. So that is 2. Alright, so of course you can do this with your calculator. 1 divided by 0.5 should still give you this. So 2 is the value that we should look for. Alright, so where do we find that? We have 2.0. Okay, so option D is the right option. Please do not forget that you have to hit that like button for us. Also click on the subscribe button and always tap on bell notification for you to get informed immediately we upload the next video. Question 8. We have density of the liquid, acceleration due to gravity, type of container of the liquid, the constituents of the liquid. So which of the above conditions will not affect the pressure of fluid? Alright, so what will affect pressure of fluid? Okay, we talk about density, we talk about depth, then we can talk about acceleration due to gravity, because we should note that as acceleration due to gravity decreases as depth increases. Alright, so these two should affect, okay, the pressure of a fluid. So which of the above conditions will not affect? That is the requirement of the question. So that should be 3 and 4. So option C is the right option. 9. If a load of mass 10 newtons stretched a cord by 1.2 centimeter, right? So what is the total work done? So the total work done here is the product of the average force, okay, multiplied by the extension or displacement produced. So I should have my W as half Fe, right? So I should have 1 over 2, right, times the force, that is 10, times the extension is actually 1.2 centimeter. If I want to bring that to meters, right, so you can see I have to divide. All right, so if I divide that, that should give me, basically it was 1.2, isn't it? My 1.2, I can convert it to 12 over 10, right? So I want to bring it to meters. Okay, that will just be times 1 over 100. Okay, so I should just have, so let me not just beat around, I should just have 12 over 1000, okay, or I can have 0.012. So if you are converting from centimeter to meters, you just divide by 100, then you get your answer. So this is what I have right here. So I did this because I don't have calculator. So you can just punch in your calculator 1 over 2 times 10 times 0.012. Okay, to make it easier. Okay, so I have 2 here 1, I have 2 here 6. So basically I have 6 over 100. Okay, that is 6 times 10 raised to the power minus 2. Or if you want to have your presentation in decimal, that's 0.06. So let's see which of these values, okay, are given to us, which of them. Okay, so let's go back to the screen to select. So 6.0 times 10 raised to the power minus 2 joules, okay, the unit for work done. So option A is the right option. 10. A plastic sphere floats in water with 50% of its volume submerged, okay. So if it floats in glycerin with 40% of its volume submerged, the density of the glycerin is what? Okay, so I'm just going to use very simple steps. Okay, so density, we have mass over volume, right? So let's determine the mass of what we are talking about right here. So we know the density of water, you can take it as 1000, right? 1000, if I cross multiply, that is volume times this, okay, times 50% of the volume submerged, right? 0 cancels 0. I have 5 here 1, I have 5 here 2, I have 2 here 1, I have 2 here 500. So the mass I have here is 500. So let's go to the glycerin. As well, I'm going to use density equals mass over volume. Of course, when you go to our site, in my school website, okay, once you click the link, it's going to take you there. There's another solution that we have provided, just another simple step as well. So you can try out various steps, but this is very easy. I feel, okay? That's what I think. Okay, so we're asked to find density of the glycerin. The mass, we've gotten the mass as 500, right? Over the volume is actually 40%. Okay, so that means I'm saying 500, right, divided by 40%, which is 40 over 100. That to me is 500 times 100 over 40. Isn't it? So 0 cancels 0, right? I have 4 year 1, right? Then I have 4 year 25. So 25 times 50, I should have 1250. 1250. So let's see if we have 1250 provided in the options. Okay, so alongside this unit, kg per meter cube. Okay, so I have that in option B. So option B is the right option. Question 11. The thermometer whose reading is indicated by a change in color of its thermometric property is the optical parameter. I know we use this device when you want to measure temperature, okay, without contact. You know, we are talking about overheated materials, something like a furnace, molten metals, and the likes. Okay, so the correct option is option D for the optical pyrometer. Question 12. At 4 degrees Celsius, the volume of a fixed mass of water is what? So at that temperature, if you understand the anomalous expansion or behavior of water, all right, so at 4 degrees Celsius, you should know, or you know, that the least volume of water is at this temperature and the maximum density is at this temperature. So if I have this question presented with the volume of a fixed mass of water is minimum at this temperature and the density is maximum. So the correct option is option B, of course. 13. An electric heater rated 220 volts, 1000 watts is immersed into a bucket full of water. So calculate the mass of water if the temperature changes from 30 degrees Celsius to 100 degrees Celsius and the current flows for 300 seconds. So I'm just going to use PT equals empty, PT equal empty delta theta rather. Okay, so I have this. All right, this is change in temperature. So the power is given as 8,000, all right, times the time, which is 300 seconds. If I want to convert that to minutes, that should be 5 minutes. Okay, so we have to look for M. So I'm dividing by C delta theta, right? The C is actually the specific heat capacity of water, which is 4,200, right, times change in temperature. You know, we are told that the temperature changes from 30 degrees Celsius to 100. So that is 100 minus 30, that is 70. So my temperature change is 70, which is the mass for the mass we are. Okay, so we have this, right? Then I have this as well. Then I have this. It's gone. I have 3 year 1. I have 3 year 14. Yeah, very well. Then I should have as well. Okay, this should be 1,000, please. This should be 1,000, not 100. The power supplied. Okay, then I should have 2 year should be 7 as well. 2 in 100, that should be 50. So end of the day, I should have my mass as 50 over 49. 7 times 7, denominator, right, equals M. So this should give me 1.0 something, yeah. Okay, I think 1.02. Yeah, 1.02 to put. Okay, the unit is kilogram. So let's go back to the screen to select 1.02 or 1 point something. All right, so yeah, 1.02. Okay, that was very good. Option C, so option C is the valid option. So you may have questions you'd like to ask. All you just need to do is to click on the link in the description below. It's going to take you to the Myschool website. Right there you get to ask your questions right now, and our solution providers are going to help you out. So join me as I solve question 14. So if the pressure of the vapor on top of an enclosed liquid is equal to the atmospheric pressure, what will be the temperature of the liquid enclosed? If, for instance, I'm taking this liquid as water, okay, so that should be 100 degrees Celsius, and that's definitely boiling point. So for any liquid at all, we are talking about the boiling point, where the VP, vapor pressure, is the same thing, or it equals the atmospheric pressure. So that is where we talk about boiling point. So option B is the right option. So you may have better solutions to offer. All you just need to do is to use the comment section below. Kindly indicate the question number and the explanations or suggestions you'd like to share. Question 15. A heating coil rated 1000 watts is used to boil off completely 2 kg of boiling water. So the time required to boil the water is what? So we have specific latent heat of vaporization of water. It is giving us 2.3, right? It's giving us 2.3 times 10 raised to the power 6. All right, so we're just going to use this formula. Okay, we're going to use Lm equals PT. You remember from our specific latent heat of vaporization formula. Okay, so this is what we have. All right, so the L is supplied as 2.3 times 10 raised to the power 6. So I have 2.3 times 10 raised to the power 6 times the mass is given as 2, right? And the power is given as 1000. So I'm going to divide both sides by 1000 since we are looking for the time t. So over 1000. Okay, I can rewrite this as my t equals 2.3, right, times 10 raised to the power times 2, yes, times 2 here, times 10 raised to the power 6, right, times 10 raised to the power minus 3. Because 1000 is actually 10 raised to the power 3, but because it is under right denominator, if I'm breaking it up, the 10 raised to the power 3 will attract a minus sign, isn't it? So I have 2.3 times 2, that is 4.6. 2 times 3 is 6, 2 times 2, 4. We get that, right? Okay, so this is 10. So that will be 10 raised to the power 6, right, plus, into brackets, minus 3. That is 10 raised to the power 6 minus 3. At the end of the day, I have 10 raised to the power 3. Okay, you can actually use your calculator to simplify this process for yourself. So my answer should be 4.6 times 10 raised to the power 3. So let's go back to the screen to sort out that presentation. So we have 4.6 times 10 raised to the power 3. So please be very careful of the exponent. So option D is the correct option. 16. It is observed that water will wet a clean glass because why? Okay, so if you want to really explain capillary action, we need two basic concepts, which are cohesion and adhesion. All right, cohesion, you are talking about the attraction between molecules of the same kind. Adhesion, different kinds. All right, so so this presentation we have, it is observed that water will wet a clean glass because the adhesion of water molecules to the glass, all right, or with the glass is stronger than the cohesion of water molecules to themselves. All right, so the adhesion between water and the glass is greater than what you have between water and water molecules. So that's what we have in option D. So option D is a valid option. 17. A man standing 2 meters from a charcoal fire is warmed mainly by what? That is radiation. No radiation, you don't need a material medium. Okay, we're talking about transfer, okay, of energy. It's energy, to be specific right now. All right, from the hotter region to the colder region without hitting the medium itself. So basically, we do not need a material medium for radiation to occur. When you could talk about conduction rather, and convection, you require a material medium. So samples or examples of radiation, you talk about how the energy from the sun reaches us, right? Or when you stand around the fire, okay, how you tend to receive or feel heat from the fire. You can see there's no physical contact between you and the fire source. All right, so that is radiation, radiant energy. So the correct option is option B for radiation. We've come to the end of this video lesson, but there are definitely more interesting content to come. All you just need to do is to hit that like button. Also click on the subscribe button and always tap on that bell notification for you to get alerts immediately we upload the next video lessons just for you.